was really, like Philip said, that is the first our full meeting, starting from the beginning of our university. And welcome once more in Krakow, in AGH University Science Technology. And maybe some of you remember our meeting in Brazil when we prepared the project. It was 2 years ago. And I promise, and we promised together, to have the friendly meeting in each our city. And I promise you to welcome you to Krakow, to the Wieliczka, the mining salt, to the AGH, because I was sure that we succeed. We get the project, we be together, we open the Space University for Europe. And it happened. You are here, and we are very glad that you have some possibility. Short introduction, few words only about our school, about this place, our group, the host group of our university. You know, AGH University of Mining Metallurgy has 100 years old. I not present the presentation because you can find any fact in our webpage and you can be familiar in our school. But what is important, we are just now in the heart of each university. It's an assembly hall where the most important meeting and ceremony take place. Here we have the ceremony of doctoral nomination, professor nomination, meeting of our board, and everything what is important. So welcome here. You see gallery of our rectors, 100 years activity of AGH UST. Each rector has a place on the wall. Okay, now, excuse me, I'm very honored to introduce our group, my colleague, vice rector of our school. I have here, you know, Rafał Wiśniowski, vice rector for cooperation, the member of the UNIVERSEH, Professor, by order, Professor Daniko, Rafał Daniko is vice rector for students, Professor Wojciech Łużny, vice rector for education, Professor Tadeusz Tylejko is director for general affairs, and Professor Marek Gorgoń, vice rector for research. So it's our fantastic group working together, and in UNIVERSEH we also your colleague, Professor Tadeusz Ul, the director of the Center for Space Technology, AGH. Space now is one of the main topics in our mission, in our activity. So thank you, I'm very glad that we're working together and we have a lot of plans in education, the research and organization relating to the space perspective. But space perspective is UNIVERSEH perspective. I want to show you the short movie, excuse me in Polish, but it is text in English. But I want to show you the movie prepared by our students. It's this movie about the AGH UST for our candidates, for our kids, for those who want to invite to the university. And I ask my colleague on this door to start the movie. Nie, kto to startuje? Nie ma? Nie, they should start.
Czy wiesz, że studia w AGH mogą być dla Ciebie niesamowitą przygodą?
AGH.
Can
Co
I
takiego? Na pewno o nas słyszałeś, ale może
switch off
niektórych
the
zaskoczymy.
light?
Nie jesteśmy tylko największą uczelnią techniczną w Polsce. AGH to uniwersytet. Około 21 000 studentów zajmuje się nie tylko naukami technicznymi i ścisłymi, czy naukami o Ziemi, ale również naukami społecznymi z uwzględnieniem aktualnych trendów światowej nauki i biznesu. Ponad 2000 pracowników naukowo-dydaktycznych na 16 różnorodnych wydziałach wspiera studentów w odnalezieniu własnej drogi i pozwala na rozwój w wybranych przez nich dziedzinach. AGH jest członkiem konsorcjum UNIVERSEH, czyli Europejskiego Uniwersytetu Kosmicznego dla Ziemi i Ludzkości. Zadaniem AGH jest m.in. rozwijanie badań i kształcenia z obszaru inżynierii kosmicznej. Dzięki statusowi uczelni badawczej i świetnej ofercie naukowej elastycznie łączymy naukę z badaniami, umożliwiając zaliczenie przedmiotów w ciekawy i praktyczny sposób. Na przykład poprzez udział w studenckich projektach, grupach konstrukcyjnych czy pracując w małych grupach, ucząc się i eksperymentując pod czujnym okiem ekspertów. Koniec wstępu. To nie spot, w którym bez końca pokazywać będziemy nowoczesne laboratoria i opisywać każdy wydział, czy wymieniać wszystkie nasze osiągnięcia. Te informacje znajdziecie bez problemu w internecie oraz w innych naszych materiałach filmowych. Wierzymy, że uczelnia wyższa to nie tylko budynki, zajęcia i wyniki naukowe. Nie boimy się inwestować w pasję naszych studentów i pracowników, bo to właśnie one napędzają naukę, pomysłowość i prawdziwe sukcesy. Dzięki niesamowitej różnorodności inicjatyw naszych studentów i pracowników, działalności 160 organizacji studenckich, w tym 140 kół naukowych, widzimy, że przodujemy w konstruowaniu zeroemisyjnych elektrycznych łodzi wyścigowych. Budujemy samoloty solarne, elektryczne motocykle enduro oraz bolidy wyścigowe. Występujemy w najbardziej prestiżowych zawodach i mamy zamiar podbić cały świat, a może nawet i kosmos. Wspinamy się, żeglujemy, wysadzamy rzeczy w powietrze, robimy filmy, konstruujemy, gramy i śpiewamy. Tak, mamy nawet orkiestrę reprezentacyjną oraz chór i orkiestrę smyczkową. To nie wszystko. AGH to także najlepsze media studenckie. Prowadzimy filmowy dom produkcyjny, rozgłośnię radiową, agencję fotograficzną czy własne wydawnictwa. Nieważne, czy studiujemy, czy pracujemy na uczelni. Kampus AGH to nasz dom, z którego jesteśmy dumni i ciągle się dla Was zmieniamy. Tak się składa, że mamy również całkiem niezłą lokalizację. Z rynku głównego dojdziecie do nas w 10 minut, a nasze słynne miasteczko studenckie znajduje się zaraz obok. Poza nowoczesnymi domami studenckimi znajdziecie tam korty, boiska, akademickie centrum kultury, klub studio, które nakręca kulturalne studenckie życie Krakowa. Co ciekawe, mieści się tam browar górniczo-hutniczy. Tak, na AGH mamy nawet własne piwo. Kiedy nasi studenci odkrywają, że jest coś poza miasteczkiem studenckim, Kraków staje przed nimi otworem. O stolicy Małopolski powiedziano już tak dużo, że puścimy Wam teraz parę ładnych ujęć z drona i przejdziemy do sedna. Są w Polsce miejsca ciekawe i ciekawsze. Małopolska wydaje się nam być tym drugim. To tutaj tego samego dnia możecie żeglować pomiędzy średniowiecznymi zamkami i zdobywać najwyższe polskie szczyty. Co ciekawe, nie tylko się wspinamy, ale prowadzimy tam również badania. Ponoć już nikt nie ogląda dłuższych filmów, więc już kończymy. Rzućcie okiem na nasze media społecznościowe, gdzie znajdziecie najświeższe informacje i poznacie nasz styl życia. I pamiętajcie, AGH to miejsce, gdzie powstają idee, rodzą się sukcesy oraz przyjaźnie na całe życie. Do zobaczenia w AGH!
See you in AGH, so like you. So excuse me, because it was the promotion movie, but prepare by student for students. So I promise that the next time I have the full English, comments. But some of the facts you see here, you can get this day just after this meeting. We want to show you the basement and construction of this new center of AGH, headed by Professor Tadeusz Żul, Center for Space Technology. Tadeusz, few information about it, and next my comments.
Thank you very much. I have got 5 minutes to present the center. There is
No more.
No more. That's,
This a cosmic,
I understand this. That's the center. The mission of the center is research and education in the field of the new space to accelerate the sustainable development of the country. But the short-term mission is to launch microsatellites into LEO orbit. That's with a special sensor which we also design. That we will have dedicated laboratory in the center. We have very good cooperation with companies from the space sectors. That we are working in the scientific research projects. We are implementing the new methods of didactics because we are the part of UNIVERSEH projects, and also we are trying to create job places to convince students to start up companies. There is a center, there is a building that is under construction, this building here. That's we will move to the building at end of March 23, almost next year. Yeah. Okay. There is a satellite mission which we plan. That we designed a deep infrared sensor. There is a sensor, there is a frame, and some data. Also, we are building the ground station, but not the campus, but the 15 kilometers from campus at the airport Pobiednik. This is a general aviation airport in Krakow. That's also we are organizing the laboratories. This is a satellite test laboratory. This is a shock and vibration test. There is a vacuum thermal chamber for test of satellites. There is also some unique experimental rig. This is a lunar surface environment simulator. Means a dirty thermal vacuum chamber. There is some in the world, but our is a little bit different and unique to test, to make some tribology test of the appliances which will be launched to the moon. That is also a satellite integration laboratory, mainly for research and also for the students. We know such laboratories in different universities, and we will try to have very similar with a clean room with a class ISO 5. There is some project which we are doing just now. The leader of this project is Dr. Agata Kołodziejczyk, and this is a very short film about that, what we did just last week. This is a near space mission of the stratospheric balloon. We started from lower, go to up and up with our project. And very short presentation. Dr. Kołodziejczyk leads the students with this mission. And I will speedy up this film. Okay. The payload is thermal camera and also multispectral camera. That is the view from the multispectral camera. And there is a road of the this is altitude 33 kilometers for the one, and there is a 35 for the next. There is a road of these balloons. And both was found, and there is there is a trajectory of the balloon. And okay, we will stop this. There is a laboratory of Dr. Kołodziejczyk. This is a life science for space. We have got the agreement with Agriculture University, and we are doing experiment with regolith, plants on regolith, and so on. And the last, it is a smart materials and structures laboratory. And what we are doing, we are trying to design the new sensors for space applications, but also we started to make some 3D printing for the constructions on the moon with a regolith. This is a special kind of 3D printing. Thank you very much.
Thank you, Professor. Of course, is in compact sheet form the example of our activity. So I can confirm that among 25,000 students in our school, this space education is one of the top perspective, and you can see during this meeting and maybe the next how we develop it is. And now please feel invited in year on the March 23 or the spring on 23 to open our new building. Philip, please put this into our UNIVERSEH calendar. Of course, thank you very much. If some question during the meeting, we can answer it. But now we continue, and I must introduce our special guest, is a director of Polsa, Polish Space Agency, Professor Grzegorz Wrochna. Professor is one of the member of our network, but in Poland, this is a minister for space. So thank you for coming, and thank you for the presentation showing the activity of Poland in the space technology. Professor, it's your floor.
Thank you very much for the kind introduction. Indeed, I have a pleasure to present you the status of the Polish space sector, but also its roots and the plans for the future. Our roots, in fact, are rather deep. Let me start with Mikołaj Kopernik, the famous astronomer you all know, so I don't need to introduce him. Also, Jan Heveliusz, he was the one making quite a detailed map of the moon, one of the first one. But then in the 20th century, a number of Polish origin engineers participated in the Apollo program, making important contribution, designing the rover, engines for the lander, power supplies for the apparatus, and so on. Another important milestone of our space sector is the creation of the Space Research Center of the Polish Academy of Sciences in 1976. And I have to also mention our most famous science fiction writer, Stanisław Lem, because he inspired generation of young and not so young people to work in the space sector. So it has to be mentioned here. But if you think of modern rocket technology, one has to also remember about Ignacy Łukasiewicz, who was in fact the founder of the oil industry. He was the first one making a fuel out of petrol, okay? And then if you want to have fuel to be useful, you have to have some oxygen. And Karol Olszewski and Zygmunt Wróblewski were the first who made the oxygen liquid. So this is our tradition. Also, one should mention Polish origin scientist Konstanty Ciołkowski, the pioneering theory of the flight of the multi-stage rockets, a theory of liquid fuel rocket engine, and so on. And also Ari Stenfeld, who calculated orbits of the spacecraft, including famous Sputnik 1. Now, in the 70s, we begin to produce apparatus to fly on the space mission. Well, the first one was on the suborbital rocket in 1970. It was X-ray spectroheliograph. Then the first one in orbit was in 1973. This was on Copernic 500 satellite, celebrating the 500th anniversary of Mikołaj Kopernik. And then in the program of Intercosmos, there were something like 24 Polish instruments. You have here some examples, instruments to study phenomena in excited ionosphere, a camera on the module Mir, and so on. We also had one Polish cosmonaut. We called the time in 1978. Mirosław Hermaszewski made 126 orbits around the Earth. And now, in the new century, we enter European Space Agency in 2012. Our agency was established in 2014, Polish Space Agency, Polsa for short. We are executive agency of the Ministry of Economic Development and Technology. Polish government adopted Polish space strategy in 2017, and now we are working on the national space program, and I will give you some details on the program. But before that, just the space sector in Poland in a nutshell. Around 400 companies involved, 80% industry, 20% research, 60% among the industry are SMEs, In total, we counted about 12,000 employees in the space sector. Concerning the public investment, we pay contribution to European Space Agency about 44 million euro a year, national grants about 20 millions, national subsidies about 6 millions, EU grants 3 millions. If you add some private investment, it will be in total about 100 million euro per year. So maybe it's not a very big number, but I think that thanks to this, I mean, the sector was really born and it's growing really fast. Let me just present you a quick SWOT analysis of the sector. Our strength is the high innovativeness, high quality workforce, proactive aptitude. The weaknesses are limited space heritage. There is one you have seen, but it is nothing compared to France, for example. Rather low level of investment so far. Opportunities, well, I mentioned the National Space Program. We believe this will be a real breakthrough. And the threat is a competition from established players. It is not so easy to compete with them or to cooperate with them. You have logos of some of the companies, and they are busy with scientific sensors. This is our first specialty because, as you have seen, the sector was grown from the scientific institutions. Ground penetrators for space probe, robotics, automation, mechatronics, onboard power supply system, optical and communication system for satellites, software testing system, and subsystem of object launched into orbit. So far, we've got 16 satellites from Poland. 11 of them are still in orbit. Let me mention just one called KRAK-SAT, and it was produced by this university, AGH University. It was the first in the world nanosatellite that uses a magnetic fluid to control the orientation. So still within this limited heritage, we have something which was the first in the world, and we are very proud of that. Now we actively participate in European Space Agency missions. We have counted that we participate in 11 out of 24 ESA missions, current missions and ongoing missions. Let me give you just some examples. The Rosetta mission, this was a kind of a hammer which was supposed to go into the comet. In fact, the hammer was working successfully, but it was very difficult to keep the instruments to the comet, so only a few inches were probed. Next one, I would like to mention the Cassini-Huygens mission, sensor for measuring temperature and thermal conductivity. The ExoMars, some power supplies. Another missions, Mars Express, again, power supplies for the scanner. Solar Orbiter, this is more serious experiment, but this is for the future. An X-ray spectrometer in a wide range. Other future missions with Polish participations are JUICE to go to the Jupiter, Bepi Colombo, when we want to make maps of the Mercuries. Proba-free solar panel deployment and release mechanism for onboard coronagraph. This is very interesting mission, having two satellites, one making a shadow of a sun, so the other one can photograph the corona. Euclid 2024, mechanism for deploying, moving an antenna and communication. And finally, Athena for 2034, mechanism supporting and releasing the telescope mirror. So maybe small components, but rather crucial for the mission, are assigned to Polish companies or institutes. What about the future? We witnessed a new space phenomenon, and I believe that this provides some advantages for young agencies. We can now build smaller systems and satellites using components out of the shelf. We can build constellation of satellites rather than one big satellite. We have private investors and companies. All this results in a lower cost, faster development, opportunity for small national missions, and the space agencies, they do not need to organize everything from scratch. We can rather play the role of the integrator. We can, of course, participate in the larger missions through international cooperation, and I've given you some examples so far. What I mean by being an integrator? Well, we need to recognize the need of the public administration and society we need to follow the scientific development, and we need to encourage the industry to use this scientific development from the universities like this one to address the needs of the public administration and the society. Another dimension of the integration is building a critical mass for the projects, industry, science. I mentioned those are small companies, so we need to put several together to create a mission. And of course, we need to help emerging companies to enter the market. So the National Space Program has 4 priorities, therefore. The first one is to have a capacity for building spacecraft and launch them. By spacecraft, we mean everything from nanosatellites, small satellite, microsatellite, built on our own, up to the big missions when we work in international cooperation. 2 other priorities are about Earth observation. The second one is to build our own small constellation. The third one is to build a data center, entire downstream, in fact, for that. And the fourth one is about the National Space Security System, namely observing the satellites on orbit, avoiding collisions, and so on and so forth. Let me just briefly go through the priorities. We have already launched a first call for space mission concept, and we've got something like 9 offers with 16 concepts related to outer space research, optical and radar observation, technology development projects, and telecommunication and navigation. Most interesting one was perhaps related to the mission to Moon, and therefore we are now asking for a consortium to prepare the whole mission. Why Moon? Moon is now priority of US and many other countries. 51 missions, as far as we know, are prepared to go to Moon by 2030. Moon is also a place to start the Mars mission, and if you count everything on that, it is a market which is estimated to be 2.7 billion annually. So it is important to be in this endeavor. Therefore, we think of a small national technical mission, something like 20 kilograms, with a robot and having some tools for drilling, some cameras for imaging the samples, the automatic control with artificial intelligence, and so on and so forth. And we are now calling for the consortia to participate in such a mission. Going to Moon is, if you want to go to Moon, we need to cooperate with NASA, and I had a pleasure to sign last year the Artemis Accords, which is a set of rules how to behave in the missions on the Moon and other celestial bodies. We are now talking to NASA and JPL about Polish participation in MIDEX mission like GAMO for Arcus, some simplex mission, maybe commercial lunar payload services for the mission I just described. Maybe some others. We plan soon a mission to JPL to discuss with them a kind of the roadmap to cooperate. But concerning the launchers, we begin with rockets for suborbital flights, so 100 kilometers or more, but without going into orbit. They are very important from the commercial point of view because they can offer 4 to 5 minutes of microgravity, which is much cheaper than the microgravity on board of a satellite. So there is a good market for that, and we have a number of companies and institutes developing their own rockets. We cannot launch rockets vertically to orbit in Poland, you know this very well, but recently a new method was involved called air launch, when you have a rocket under a big plane. The big plane could start from Poland and go to some safe place like a North Sea, and the rocket can start there. I have signed in March a letter of intent with Virgin Orbit having this technology. You see me on the picture making big plans, you see. We even think of the first launch maybe next year if everything goes right. We will have a visit from Virgin Orbit next week in Poland. The second priority of our National Space Program is Earth observation, constellation of the satellite. We call them micro-globe, medium-sized satellites, somewhat less than 100 kilograms, 4 optical, maybe one radar. On top of that, we would like to build what we call National Satellite Information System, gathering the data from the satellites and making them available for different applications. And we have already launched a call for pilot projects using those satellite data, land cover, detection of land cover changes, orthophoto map from the satellite, moisture monitoring, heat islands for Polish agglomeration. We also made some public administration training, some legal expertise, some initial infrastructure of the system. And the system, as I said, should be able to receive the data from national commercial satellites, free satellites like European Copernicus. It should allow to store the data, but also to archives, which is not trivial. Those are exabytes. It has to have a data catalog so users can access easily the data, can find the data, but also it should provide a computing power and an API so some companies, some institutions can add their own applications, like the one I mentioned just before, different kind of maps. So anyone can search and choose the application is needed. Another fourth priority of our program is the space safety. We already participate in the European Satellite Survey and Tracking Consortium. We provide most of the data to this consortium, having a network of 12 telescopes. We have just ordered 6 others on different continents, and we want to develop this even further. Of course, I have to mention international cooperation in this room. We are members, or we cooperate with many international agencies. It would be quite boring to read it, so just have a quick look at the logo. But let me finish with the slide of the Polish Cosmos of Youth. I mean, we really have brilliant students. They make analog missions, so they are close somewhere and they spend some time and they do whatever is usually done on the space station, for example. We have students making satellites on this university, in Warsaw University of Technology. Some of them, they already made some instrument which flown on the professional missions. We have a big competition in Poland, European Rover Challenge, and we have a number of teams building those rovers. We have students building the rockets, also winning international competitions. Even this week, I mean, 3 student teams from this university are taking part in international competitions. And we consider it so important that we have a student council attached to our agency, so we know what is going on. And this is precisely the reason why I believe that activities like yours are very important. Anytime I talk to the Polish companies and I ask them, what is your barrier? What do you need to grow? They said, young, well-educated people. So I really appreciate your work, and I hope I somehow encourage you, showing what is the space sector in Poland, how fast it's growing, and how hungry of young, educated people the sector is. So really, I appreciate your work, and I wish you a successful day today and a successful project. Thank you.
Thank you, Professor Wrochna. You can see our partners that also in Poland, in our Polish strategy and our Polish activity and Polish government politics, space has a very important moment. So thank you, Professor, thank you, Minister, for the presentation. If you have some question here or next, but you know, adding one information to your fantastic presentation, that just a few days ago, our team of the AGH students went to US to participate in the next challenge. So we are keeping the mix because every time they are coming, we succeed. Okay, thank you, Professor. Now next presentation, we get the pleasure to present Dr. Agata Kołodziejczyk. Professor Ul mentions about your success, Dr. Kołodziejczyk, but please get more details about our project. It's your floor.
Thank you very much. Welcome, everyone. It's a pleasure and honor to be here, especially in such amazing company. Today, I wanted to tell you about students and my job because I love students. I love to work with students. And I will show you a little bit from the kitchen side how we do projects with students. Especially, we will focus on education here and on science. And also, I'm very proud to say that because I'm staying here is because of you, of UNIVERSEH. I went in October to Toulouse. I met Professor Ul, and I recognized that there is a space research center, space technology center in AGH, in my city, in Kraków. And we combined my company, Analog Astronaut Training Center, with AGH. Thank you so much. So as Analog Astronaut Training Center, we try to combine students from all around the world to study, to be prepared more to work in space sector. As you can see here, we have many people from different cultures, from different continents. It's an amazing adventure. This is just from the last year. You can see how many people I know by heart, by their name, by even their physiological parameters. I don't want to get into the detail now. So these missions are quite important in Poland. We have 2 habitats. We have LUNARES in the north of north of Poland, and Analog Astronaut Training Center here in the south. So now we have 2 centers to run analog simulations in Poland, and I think we are the only one country in Europe who has these 2 sites for students to train. Today, we have here our future analog astronaut. Today, tonight, we will run pre-training, night survivor pre-training for Sandra mission. We'll start tomorrow. But what is space analog mission? We organize 3 types of analog simulations. So as you can see here, we either organize field campaigns, and Professor Ul already showed you stratospheric mission, for example. Or we build rockets together with Space Forest Company. So we fly to 500 meters. This is our altitude with students. And we collect samples, of course. So we build pressurized spacesuits in collaboration with anthropology department, and we test these suits. We have also controlled campaigns. For example, environment which is kind of controlled, I will show you in a moment, and especially in the habitat. So first, field campaigns. Here you can see our student collecting samples in Polish Polar Station in Hornsund, in Svalbard. And we are mapping human microbiomes contamination in this region because Polar Station is kind of isolated, a virgin land. So we try to observe how humans affect these virgin lands. Also here, you see our field campaigns. You see tests of our pressurized spacesuit, which is named LEM, after our science fiction writer and futurologist. And we also try to teach students many different practical things. This is our aim, to show them some practice. Again, controlled simulation, controlled environment, underwater. We are making underwater extravehicular spacewalks, kind of, in neutral buoyancy. As you know, astronauts need to train about 8 hours per day in their training before the space mission. So we try also to run these trainings for our students. And we like extremes. So during peer training phases, before closing our students, we try to monitor their physiology, their limits, so we get an idea what we can do inside the laboratory, which is the habitat. And during pre-training, we already measure heart rate, body temperature, blood pressure, all these kind of parameters that might be affected later on in isolation. So, finally, we go to the habitat of Analog Astronaut Training Center, which is a simulator of spaceship. Why? Simply because most of the time astronauts spend in confined space in the spaceship. What is very specific to our habitat is that we have sensors. These sensors monitor humidity, temperature, CO2 levels, power consumption, and they are located in various areas, so we get an idea about a 3D mapping of environmental conditions. Here you can also see the habitat is very confined, it's 57 square meters, and we have a bedroom module, a clean laboratory. I will show in a moment what we do there. Geolab, of course, gym, 2 hours of training, and then hygienic modules. Because we have sensors and we can remotely control what happens in the habitat, especially lighting conditions and CO2 levels, then we can modulate and standardize some emergency simulations. This is not just a number on the screen, on the monitor, but really the CO2 levels are much higher, what we can observe even in our hydroponic systems, that plants are growing much faster. We collect standardized data. So from each mission to each mission, you already see we are now starting the 44th analog mission. We collect exactly the same parameters. So we can run long-term studies and we can do some science. We can play with these all data. We start from basic parameters, which are here, very general, what was the time, how many days of the mission, how was the large crew, and then how much water they drank during the whole mission, how much water they used for showering, what was their sport, fitness, activity, so how long they cycled, they ran, and so on. So from sport, we have also very standardized data. 1 hour we spend for individual training in the gym and on mic, where people collect body temperature before, after, heart rate before, after, and of course we measure the calories and steps that they did. We also measure bioimpedance, so you see for one astronaut, for each day we had all these parameters. And this is also not only heart rate, blood pressure, temperature, saturation, but also body fat, weight, BMI, and biological age. We try to measure sleep quality using different methods, but here I will show you only very simple method by using a band. And we try already to get as much information as possible in order to understand how you sleep in isolation. We believe that this is a very crucial parameter for future space missions. Also, very crucial parameter are circadian rhythms. My background is circadian rhythms. I was studied this in Sweden, so I try to continue this study, and they are very interesting results, especially in isolation. We compare our studies in 1 week isolation, 2 week isolated missions with people living in Longyearbyen in polar region during polar night, and we compare all this data together. Finally, already as a fruit of this collaboration with Space Technology Center, we already developed an application that will be used in mission that will start tomorrow, the subjective time perception application, which can be available for everyone, and we can make the first citizen science experiment to collect even more data about circadian rhythms and subjective time perception. Also, we are specialized in kind of gravity projects. We develop by our own special tools like hypercentrifuges to induce different types of gravity like 2Gs, 3Gs, 5Gs. Then we have clinostats for plant growth and for averaging the vector of the gravity and going to zero. And same for 3D machines, which are random positioning machines. Our students are building these type of instruments. They are testing them and they run research. Another thing that we develop are biomaterials, especially kombucha. All people who read maybe kombucha was a consortium of yeasts and bacteria that was exposed for 18 months on the external panel of International Space Station. And now we try to develop several types of biomaterials out of it. So here you can see how we try to produce nanocellulose and convert it into several different types of materials. Also, as a fruit of this 2 months symbiosis with Space Technology Center, we already started to print kombucha with lunar regolith simulant. We are very proud of it. And here you have also some projects that we develop in the habitat. So, for example, we try to reduce CO2 levels using active and passive airflows. Our students have possibility to differentiate the ventilation system and measure how it acts. Also, we try to use biofilters, bioreactors with different types of algae to reduce CO2 levels. This is very, I think, famous topic and very challenging, how to clean the water in isolation. And we try to do this together with several students. Also very difficult and hard for students is to work with regolith simulant and to grow plants that they are healthy and they can develop fertile seeds. We have also several experiments monitoring macrolife bacteria biocontamination in isolation. Very interesting study. And the final thing, we of course construct some educational CubeSats together with ESERO, which is Education Center of European Space Agency. And what already was showed, after we construct something, it always goes and is tested, not only in the laboratory, but also in near space environment in the stratosphere. And we also organized international competitions. We try to motivate, attract students to be more proactive, to also try to be creative, not only to rely on somebody, but also to be proactive. With that, I would like to thank you. Of course, if you have any questions later, I can answer. Thank you so much.
Thank you, Dr. Agata. Thank you. You see how fantastic program, and thank you for this enthusiastic, approach and how you are joining in our project, and really very perspective, program for everyone. So we welcome to the project headed by Dr. Agata Kołodziejczyk, and especially for students. Maybe the question during the break, during the meeting, we are together today for 2 days, so we have occasion to discuss. And the last example, I want to introduce our friend, our member of our faculty of Drying Oil and Gas, Dr. Krzysztof Skrzypaczek, the program for space mining study. Krzysztof, please, your floor.
Dear Rector, dear Professor, dear guests, my name is Krzysztof Skrzypaczek and I am researcher at the Faculty of Drilling, Oil and Gas. I'm very pleased to be able to present to you in this short presentation the effect of our 1.5 year work on a unique specialization called space drilling. The team working on the specialty consists of the Drilling, Oil and Gas faculty member listed on this slide. In addition to myself, they are Adam Zwierzyński, Przemysław Toczek and Tomasz Kowalski. The head of the specialization and the main mentor is Professor Wiśniowski. Thank you, Professor, and we look forward to future fruitful cooperation. First of all, I would like to thank Rector Jerzy Lis for the support of our university authorities so that we could bring our project to a successful conclusion. I would also like to thank the director of the Space Technology Center of our university, Professor Tadeusz Uhl, for his invaluable assistance, consultation and support for our project. Thank you, Professor. Our university is boldly looking towards space, and I think that the new specialization may be a good pilot program for education in the conversion of classical technologies for the needs of the space sector. On the current slide, I present the structure of education at our faculty and the place the new specialization space drilling has in it. Generally, the specialization is a part of scientific discipline, environment, engineering, mining, and energetics. Our specialization is related to the second degree studies and will have 3 semesters long. Inaugural semester is planned for March 2023. Why now? I usually answer this question by comparing the situation to the development of computer technology in the 70s. At the time, there were also very innovative technological solutions and a large group of skeptics. Nowadays, information technologies are everyday life for us, and information technology companies provide work and life on high level for millions of people. Continuing that, the world has changed. Advances in rocket technology have made it possible to lower the cost of launching payloads into space. This caused the dynamic development of the space industry, which will accelerate along with further reduction of the cost of launching cargo into space. The global value of the space sector in 2019 was $366 trillion dollars, of which only about 100 billion was government spending, and the remainder was generated by the private sector. According to the report, Opportunities for Space Resources Utilization, Future Markets and Value Chains, prepared by Luxembourg Space Agency, it will work full-time in space mining until 2045. it will be about 1 million employers will employ nearly 2 million workers in the space sector. Although the Polish space industry is young, it's going through a period of dynamic development. Poland has been a member of European Space Agency since 2012. In November 2020, UNIVERSEH was created, of which our university is a member. In 2021, Poland signed the Artemis Accord agreement. Why the Faculty of Drilling, Oil and Gas? We have over 11 years in the space industry, including knowledge transfer, cooperation with the Space Research Center of the Polish Academy of Science, one of the first faculties at our university to implement European Space Agency projects. On the slide, I present the participation of our faculty in various projects for the space sector. We are pioneers of work of the development of an analog of the lunar regolith. We work on a mobile drilling rig for drilling in extreme space conditions. A specialized drilling module is developed for the needs of future space mission and international patents. Probably the first master's thesis in Poland on the exploitation of water from ice deposit on Mars. The work took into account the issues of deposit and drilling. Today, 2 new European Space Agency projects are launched at the faculty. Commercial exploitation of space resources requires their recognition and confirmation by in situ methods, geological methods, reservoir engineering, gas and fluids processing. Geoengineering methods will also be needed in space. The Faculty of Drilling, Oil and Gas is a unique one, only a few units in Europe with over 50 years know-how and experience. It has also over 11 years experience in space project. On the slide, we present the numbers related to the specialty. The total number of classes and lectures is about 2,250. We are supported by leading Polish companies from the space sector, for example, Sad Revolution, Tech Ocean, ICE, Astronaut. On these slides, I present the program of the specialization. It's a lot of lecture and classes. Finally, I would like to thank the people who helped us a lot so that we could achieve our goal. In the near future, we want to establish cooperation with a Polish Space Agency, and we want the next edition of the studies to be entirely in English. Thank you for your attention.
Thank you, Dr. Krzysztof Krzypaszek. You know, this is an example of the beginning of our education program. All the specialization is English, so in 2 years or 1.5 years we'll give the first diploma, and specialists asked by Dr. Wrochna, we are ready for the job market. Okay, so Philip, we finish our official program. Now is the time to close the General Assembly, General Meeting, and the next program is a steering committee. So the steering committee is present here and we continue the meeting, okay? The closing ceremony for this.
Just a few words to thank you and to thank all the people who have made such interesting presentations for us. I was putting a word on the social media to say that we were in space thanks to you. So thank you very much.
Thank you. The short break, for coffee, tea, so enjoy the coffee and we continue in few minutes. Kto teraz zostaje?